This is the assembly of the first gear-to-gear transfer in the drive system. Most of these parts were manufactured on my lathe, and for centering, it's incredibly important to get the location of the various parts as close to center as possible. Usually within a thousandths or a half thousandths would be better. For doing this, I use these soft jaws. The idea is to mount these soft jaws in the chuck, and once they're mounted, then you can turn them to the appropriate diameter. Since you're turning them to a diameter while they're in the machine, it guarantees concentricity between the location of the radius and the location of the spindle axle. Once you get the right diameter, the gear fits, and they fit perfectly. There's a lot of surface area contact, and so as you put in gear after gear, it's going to locate it very, very precisely. The starting piece for this assembly is this, if I can get it, is this, which is manufactured in the mill. This piece contains these steel pins, and the steel pins represent the roller parts of a chain. Now, these pins are press fit in, which means that the holes are drilled like a thousandth of an inch undersize, and then the pins get pressed in so that you have interference fit between the pins and the aluminum. Everything on my robot will be press fit. You might find a set screw here or there for things that don't really take load, but set screws are terrible. Never use them for combat robots. Even keyways are bad. If you put a key in a keyway and a gear, there's liable to be just a little bit of slop in the key unless you do size on size fitting. If there's a little bit of slop, then as they take load reversal, that key is going to get accelerated and slammed into one side of the slop, and that's going to deform the material. Over time, those reversals are going to deform the material more and more until eventually you'll have a breakage. If you interference fit things at the right level, you are never going to have that issue. Of course, it makes it entirely impossible to take apart, but for most things in BattleBots, I don't think I need to worry about taking things apart. They're either going to be working or they're going to be broken. We start with this piece. This is the interior part of the clutch. I've added this bronze bushing. Put it together. Add the friction clutch plate from the original clutch. Add the gear. All right, and it's a little sloppy. That's because we have this Delrin centering piece. It's pretty tight, so it's going to take a little work to get it on. Get it all lined up, and it drops down inside. Now, to push on that Delrin gear, I have 2 wave springs. I can stack up to 4 in this design depending on how much load I need. Right now I am going to try out 2. And finally, to retain everything together, this is a small remnant of the original super heavy nut that held everything together. There is a place for a set screw here, and the set screw doesn't attach or doesn't load anything. It goes between the various spikes on this circle, and it keeps the nut from backing off too much. Now this This thin nut is going to be very difficult to get to go to start on the centerpiece here. It'll take a little finagling because it's a big fine thread, and fine threads don't like to start without a lot of guidance, and this has very little guidance. So I have to find the start of the thread and get it to match up. It just takes time to locate it. Luckily, this does not get assembled very often. Likely the clutch will be installed. It will be run in for a couple of hours, and then it will be taken out and retorqued. I am going to have to build a fixture so that I can measure the slip torque here. And once I can measure the slip torque, I can set it so that it is slightly higher than the maximum output of the motor. That way, all the motor torque can go through, but a reverse load trying to get back into the motor that's higher than what the motor can generate will not go through. And this is being a little bit of a pain in the butt, but as a fine thread, there we go. You can have that. All right, we start loading. It's just a little loaded right now, and so you can still spin the sun of the chain Planetary relative to this gear. And eventually I'll end up building a tool that will fit into these 3 notches that will allow me to more carefully control the nut. But right now I have vice grips. There we go. Okay. Something slipped a little into place. All right. Okay. This will, again, I'll have to make something that I can put into these holes and grab the back with and test the actual torque. But that is the system as assembled.